Hello and welcome to section 5-3 exercises numbers 21 through 26. Here we're factoring each trinomial. Now in these trinomials they break up into two different ways. Those with leading coefficients 1 and those with a leading coefficient not 1. And you'll notice all of these have the leading coefficient not 1. And this factor right here, this coefficient, kind of messed up our shortcut that we used in the last few problems, which was just we look at what times to 10 and adds to 17 or something like that. Now we use the AC method, which means we take this, let's write it over here, ax squared plus bx plus c. We take a times c and we put it over here, and that is what we factor and then split b with. So that's the idea. We got to take a times c and put it right here. So let's do that. 3 times 10 is 30. And then we look at all the factors of let's put the sign on there, positive 30, 1 and 30, or we get 2 and 15, or 3 and 10, or 4, nope, not 4, 5 and 6. Do any of these add to 17? It is that one right there. So this is really 3x squared. That 17x came from a plus 2x plus 15x. So we uncombine terms into the right numbers to make this thing work. All right, so now we have 1, 2, 3, 4 terms. We know how to do this guy. We saw this in half. And we pull out what we can from the front half, x, and we're left with a 3x plus 2. And what do we pull out of the second half? A plus 5. And we're left with 3x plus 2. So when we pull out the 3x plus 2, we have 3x plus 2 right there, and we have x plus 5. And again, you can pull the 3x plus 2 out to the right or to the left, either way, and it will work because these two factors are now multiplying each other, so they follow the commutative property of multiplication. All right, what's the next one here? Number 22, 14 times 3, that's 42. 42, what goes into 42? Certainly a 1 and a 42. 2 goes into 42 21 times. 3 goes into it 14 times. We just did that. 3 times 14 was 42. 4 does not go into it. 5, no. 6 goes into it 7 times. Do any of these add up to negative 13? Yes, we have a negative 6 and a negative 7. Double check that that's correct. Negative 6 times negative 7 is a positive 42. And add to negative 13, correct. So this is really 14p squared minus 6p minus 7p. Again, we split that guy up into its two components, the right two numbers that add to negative 13 that will allow us to do this. So then we're like, okay, so what does that help us with? Well, now we have 1, 2, 3, 4 terms, which we can do by grouping. What can we pull out of the first two? Looks like we can pull out a 2p, and we're left with 7p. Is that right? 7p minus 3. All right. And then what do we pull out of the next two? At least that minus sign, and we're left with a positive 7p and a minus 3. Now, if you would like to see that as a minus 1 to help you identify what's happening in the next step, that's great. You can always pull a 1 out of anything, but some of you may not need to put that 1 there to make sure everything is working. So if we pull out the 7p minus 3 right there, and what's left is that 2p minus 1. Excellent. All right, next one. 8 times a negative 15 is negative 120. Oh, this one's going to be a long one. 1 and 120. 2 and 60. 3 and 40. 4 and 30. 5 and 24. 6. Yeah, 6 and 20. 7. Nope. 8. Yeah, 8 goes into it 15 times. We did that to get 120. 9. Nope, nope, no 9. 10. 10 and 12. And then 11. And then, nope, 12. Wow, that's a long list. Now remember, this is a minus sign. So when they are adding together, they have to be opposite signs. So they're really subtracting. So let's put a minus sign over here on the big ones because we're going to end up negative, and the other guy's positive, and let's see which one of these add to a negative 14. Let me see. Negative 26, negative 19, negative 14. That's our guy right there. And then this would be negative 7, and that'd be negative 2. So this negative 14x actually came from 8x squared plus 6x minus 20x minus 15. Now, the question often comes up, could I have written it as minus 20x and plus 6x? Yes. You'll notice the factor that ends up green and the factor that ends up blue, if you switch these two places, it will simply have the green be the 3x plus 2 and the blue be the x plus 5. So it just switches which one is found in two places to come out. So really it doesn't make much of a difference at all. All right, so let's do this one. And okay, cut this guy in half because we now have 1, 2, 3, 4 terms. And what can we pull out of the first half? Looks like we can pull out a 2 and an x, and we're left with 4x plus a 3. And then out of the second half, pull out that minus sign, and out of that we can pull out a 5. And if you're having a tough time in the second half, look at what we're trying to make in order to keep going. We're trying to make a 4x plus 3, so we have to pull out a negative 5 in order to leave a 4 right here. And yes, indeed, it works. So when we pull that out, we now have the 4x plus 3 there, and then the 2x minus the 5. And notice I pulled these guys out to the left. Doesn't make any difference there. All right, number 24. 4 times negative 15 is negative 60. So that's a 1 and a 60, a 2 and a 30, a 3 and a 20, a 4 and a 15, a 5 and a 12, a 6 and a 10. And which one of those adds up to a 32? Oh, this is a negative. So that means one of them has to be positive and one of them negative. So if we have positives over here and negatives over here, that might work. So, ooh, we would love it to be that 32 right there. But negative 2 times 30 and negative 2 plus 30, it would have to be a 28, so it doesn't work. Is there seriously not a combination? Double check all of them. They have to be opposite signs to make this negative 60. So we can't use a positive 30 and a positive 2. That won't work. And it is kind of fun. Just give it a try, just in case you're like, no, we can do it. Positive 30x, positive 2x, minus 15. When you cut that in half and you pull out there, you get a 2x and you get a 2x plus a 15. And pull out a 1 there, and you're left with a 2x minus a 15. Notice you are stuck. You can't go anywhere. 2x plus 15, 2x minus 15 are different, and so grouping didn't work on that guy. Yeah, I think we are stuck here. There's nothing that will add to a positive 32, so this one is prime. Can't do it. All right, let's do number 25. 9 times 4 is 36. That's a positive 36. That could be a 1 and a 36 or a 2 and an 18. Some of you will see 1 and 36. Oh, that's our 37. But we're going to keep going anyway just to make sure we get them all. 4 and 9 and 6 and 6. Wow, yeah, 1 and 36 work. So we're going to break that up into 9r squared plus a 1r plus a 36r plus a 4. And how do we do that? Yeah, we chop that guy in half. We have 1, 2, 3, 4 terms, so we are now in grouping. So pull out an r, and we're left with 9r plus 1. And out of the other side, we can pull a 4. And we're left with 9r plus 1. Great. Now pull out that 9r plus 1, and you're left with r plus 4. And there you have it. That was nice. Okay, and the last one. 5 times a negative 8 is a negative 40. It could be a 1 and a 40, 2 and a 20, 3, nope, 4 and a 10, 5 and an 8, 6, 7, nope. Okay, so what of these adds to a positive? Oh, it's a negative. Okay, these guys are going to be opposites, so we're actually going to subtract, and we need to end up a positive. So we're going to put the positives over here and the negatives over here. Subtract, that'd be a 39, 18, 6. Got it. So this breaks up into a negative 4x and a positive 10x. And again, you could have switched those two places. I think we'll do it this time just to show you that you can do it, and it's kind of cool. So let's go through this one. So we cut it in half, and right now we pull out the 5x. Nope, not a 5 and an x. Can't pull out a 5. Just an x out of this one, and we're left with 5x. Let's get that other color involved. 5x minus 4. And then we pull out, what do we pull out of here? A plus 2. And we're left with 5x minus 4. All right, so when we pull out this blue guy, 5x minus 4, and then we get what's left? X there and a plus 2 there. All right, let's do it over here, and just so you can see what would happen if we did 5x squared plus 10x minus 4x minus 8. See how we just switched those two places? It should work, right? It should work. Well, let's cut it in half. And then pull out what we can. Out of this side, we pull out a 5x, and we're left with that x plus 2. And now we pull out over here a minus 4, and we're left with x plus 2. And then when we pull out that x plus 2, we're left with that 5x here and that minus 4. Very instructive here that switching them doesn't change the actual answer. Those two are the exact same answer, but it changed which one of the factors was found in both places to be pulled out as that greatest common binomial factor, and which one is left behind. There is no difference in the answer, no problem at all, but that just shows you that you can actually switch them without any problem.